The last section of this chapter, section 7.7, has us solving right triangles. So to solve a right triangle, you're going to find the measures of all of its sides and angles. So again, by the time you've solved a right triangle, you should have the measures of all three sides and all three angles. In order to do so, you must know at least two sides or one side and one angle. So again, in order to solve a right triangle, first you must be told it is a right triangle, and then you at least need to know two of the sides or one of the sides and one of the angles. Once you have that bit of information, two sides or one side and one angle, you could solve for all the rest. So in the end, you would know all three sides and all three angle measures. In order to solve a right triangle, sometimes you're going to have to solve for one of the acute angles. So to find the measure of one of the acute angles, you must use an inverse trigonometric ratios. In the table, you see the inverse trigonometric ratios. So it says, let angle A be an acute angle. So let's say you were given the opposite side and the adjacent side to angle A. So here's angle A, and you were given this side and this side, and you're trying to solve for angle A. You would use the inverse tangent. So if the tangent of A is equal to some amount, again you have the opposite over the adjacent, then you would use the inverse tangent of the opposite side over the adjacent side, and you would be able to find the measure of angle A. Now let's say that you were given the opposite side and the hypotenuse. So you would want to use the inverse sign. So again, if the sine of A is equal to y, the opposite over the hypotenuse, then you would use the inverse sign of the opposite side over the hypotenuse, and you would find the measure of angle A. And finally, let's say, again, you're looking for angle A, and you're given the adjacent side and the hypotenuse. So you would use the inverse cosine. So if the cosine of A is equal to z, again, that would be the adjacent side over the hypotenuse, then you would use the inverse cosine of z, and that would be the measure of angle A. On your calculators, you should find the inverse tangent, the inverse sine, and the inverse cosine above the tangent, sine, and cosine keys. If you're wondering how to find these functions on your calculators, make sure you ask me in class before you tackle your homework. Now let's look at some examples. Here's example number 1. Find the measure of angle Q to the nearest tenth of a degree. So it's telling us what to round to. So we're looking for angle Q. Notice we're given the opposite side and the adjacent side. Since the tangent function is the opposite over the adjacent, I'm going to set up this problem and say the tangent of angle Q is equal to, again, opposite over adjacent, so 12 over 8. I could put that in the lowest terms if I wanted to. Otherwise, I'm just going to plug this into my calculator, and your calculator does not necessitate you putting 12 over 8 into lowest terms. So again, I can't just divide by the tangent. Tangent is a function. It's just like a plus sign or a minus sign. So in order to find the measure of angle Q, I'm going to do the inverse tangent. So angle Q would be equal to the inverse tangent of 12 over 8. So this is just as simple as typing it into my calculator. So again, typing that into my calculator, I get angle Q is about, since I'm rounding, about 56.3 degrees. So again, I'm going to use the inverse tangent of 12 over 8 since I had the opposite over adjacent, and I found that the measure of angle Q would be about 56.3 degrees. On to example number 2. It says, let angle C be an acute angle in a right triangle. Find the measure of angle C to the nearest tenth of a degree. So for part A, it says the sine of C is equal to 0.24. So again, it's not as simple as just dividing by sine. That's impossible. This is a function. So in order to find the measure of angle C, I have to do the inverse sign. So angle C would be equal to the inverse sine of 0.24. So again, this is just as simple as typing that into my calculator. So again, typing into my calculator, and it says round to the nearest tenth of a degree, I get that C is about 13.9 degrees. So this time, it actually just gave me what the ratio of opposite over hypotenuse would be, and then I just did the inverse sine and got 13.9 degrees. For part B, it says the cosine of C is equal to 0.37. So they already did the work for us. They found what the adjacent side over the hypotenuse is, and they got 0.37. So to find the measure of angle C, I'm just going to do the inverse of cosine of the 0.37 and type that into my calculator. Again, it's asking me to round to the nearest tenth, so C is about 68.3 degrees. So once again, just to tie this all up, they did the work for us and told us, like in this instance for part A, since it was sine, they told us that the opposite side or the hypotenuse was 0.24. So to find the measure of angle C, we just had to do the inverse sine. And the same goes for part B, except this time we're using cosine. So they went ahead and found what the adjacent side of the hypotenuse would be, and so all we had to do was the inverse cosine to find the measure of angle C for that case. And now on to example number 3. It says, solve the right triangle formed by the water slide shown in the figure, round to the nearest tenth. So it's asking us to solve the right triangle. So that means I need to find all 3 sides and all 3 angles. So notice in this problem, I was given an angle and a side. So remember, that was one of the ways that I would be able to solve a right triangle. Remember, one of the options is if I was given 2 side lengths, and the other option was 1 side and 1 angle. So I'm good to go in that aspect. So the way to start would be the easiest. I'm given 2 angle measures, 42 degrees and 90 degrees. So I could simply just subtract from 180 to find the measure of angle Z. So again, the measure of angle Z would be 180 minus 90 minus the 42. So the measure of angle Z would equal 48 degrees. So I'm going to write that in to my diagram just so I can keep my eyes on the prize and figure out, okay, now I have all 3 angles. Now I need to find all 3 sides. I was already given 1 side, so now I need to find this side and that side. So we need to find the measure of ZY and XY. So we're always going to work off the things that we're given. We were given the 42 degrees and the 50 degree hypotenuse. Notice that this is the hypotenuse. So let's start with finding this side. So this would be ZY. ZY is opposite the 42 degrees. Let's just call that X for now. So side X is opposite the 42 degrees, and then again we were given the hypotenuse. So opposite over hypotenuse is sine. So to find ZY, I'm going to set up the problem. The sine of 42 degrees, since again I was given the opposite side and the hypotenuse, would be equal to X, which remember is just the measure of ZY, over 50, which is the hypotenuse. Since X is in the numerator, I'm just going to need to do one step, multiply each side by 50. So X would equal 50 times the sine of 42 degrees. It says round to the nearest tenth. Although this is my exact answer, the problem tells me to round to the nearest tenth. So typing that in my calculator, I get about 33.5. But remember, X was just representing ZY, so ZY is approximately 33.5. Next, we need to find XY. So just for clarity's sake, let's call that Y. So notice this time, again, we're only going off the things we were given. Remember, we were given the 42 degrees and the 50-foot hypotenuse. So the Y value, or XY over here, is adjacent to the 42 degrees, and again we were given the hypotenuse. So adjacent over hypotenuse is cosine. So I'm going to set up the problem. The cosine of 42 degrees is equal to y over 50, because remember y is the adjacent side. So again, since our variable is in the numerator, all I'm going to do is multiply by 50 to get y by itself. So y would be equal to 50 times the cosine of 42 degrees. But again, this is my exact answer, but it's asking to round to the nearest tenth. So in our calculators, we're going to get about 37.2. But remember, y is what was representing xy. So xy is about 37.2. So again, now I have solved this right triangle because I have all 3 sides. Here's 1 side, 2 sides, 3 sides, and all 3 angles. So this right triangle is solved. Example number 4. A road rises 10 feet in a horizontal distance of 200 feet. What is the angle of inclination? Of course, let's draw a picture to visualize what's happening. A road rises 10 feet in a horizontal distance of 200 feet. So it's saying if it's going 200 feet this way, it only rises 10 feet vertically. And the road would be on top. So notice a right triangle is formed. So 10 feet it rises, 200 feet horizontally, and it's asking for this angle right here. So for clarity's sake, let's just call that angle A. And again, that's the angle we're looking for. Across from angle A, or opposite angle A, is the 10, and adjacent to angle A is the 200. So opposite over adjacent is tangent. So I'm going to set up this problem and say the tangent of angle A is equal to 10, the opposite, over 200, the adjacent. To find the measure of angle A, it's not as simple as just dividing by the tangent. I would have to do the inverse tangent. And remember, it is not necessary to put 10 over 200 in lowest terms, since I'm just going to type it into a calculator anyway. So again, I cannot just divide by the tangent, I have to do the inverse tangent. So angle A would be equal to the inverse tangent of 10 over 200. And all I would have to do is type that into my calculator. This is my exact answer, but if somebody asks you how high the angle of inclination is for a road, you wouldn't answer it as the inverse tangent of 10 over 200. You would give them an approximate angle degree. So let's type this into our calculator. And I got approximately 2.9 degrees. So if the road only rises 10 feet and a matter of 200 feet across, the road would only raise 2.9 degrees. And now on to example number 5. Solve a right triangle that has a 40-degree angle and a 20-inch hypotenuse. Remember, when you solve a right triangle, you need to find all 3 angles and all 3 sides. So far, we have an angle and a side. Remember, you either need to have 2 sides or an angle and a side in order to actually solve the right triangle. So we're good to go in that aspect. Of course, let's draw a picture first so we can wrap our heads around what we know and what we need to find out. So here's our right angle. Here's our 40-degree angle. It doesn't matter where you put that 40-degree angle, as long as you put it in one of the acute angles. And we also have a 20-inch hypotenuse. So it's really easy to find this missing angle, since we know there's 180 degrees, and so we have 180 minus 90 minus 40, so we have the other angle already. We know that's 50. So all we need to find is this side and this side now. Since we have all 3 angles now, we have one side, so now we need the other 2 sides. Remember, always go off of what you were given. We were given the 40-degree angle and the 20-inch hypotenuse. So that's what we're always going to base our problems off of as we set them up. So the 40 degrees is right here. The opposite side is the x, and we were given the hypotenuse. So opposite over hypotenuse is sine. So the sine of 40 degrees would be x over 20. So in order to find x, it would just be a one-step problem, just multiply by 20. So x would equal 20 times the sine of 40 degrees. Let's just get a decimal approximation on that. I ended up with approximately 12.9. So again, this side is approximately 12.9. So I'm halfway there now. I have one of the 2 sides I needed. So now let's find y. Remember, go off of the 2 things we were given. We were given the 40 degrees and the 20-inch hypotenuse. So to find y is adjacent to the 40 degrees. So now we have adjacent over hypotenuse, which is cosine. So to set up the problem would be the cosine of 40 degrees equals y over 20. So just like before, since our variable is in the numerator, I'm going to multiply by 20. So y would equal 20 times the cosine of 40 degrees. And just like before, we're going to get a decimal approximation. And I got about 15.3. So this is about 15.3. So now I have solved my right triangles. I have all 3 angles and all 3 sides. Just a side note, since I didn't give an example like this, if you were given 2 sides of the right triangle, like one of the requirements is, you would just use the Pythagorean theorem to find the 3rd side, and then inverse trigonometric ratios to find the other 2 angles, the 2 acute angles. We'll do an example like that in class before you do your homework in class. So, as always, jot down anything you didn't understand or questions that you have for me, and we'll cover those in class, and we'll see you then.